I recently participated in a data cleanup challenge that was organized on social media. It was a great initiative to bring the data community together to share those experiences with each other. So, shout out to everybody who was involved in organizing this. We had to clean a set of FIFA data, and we could choose which tool we wanted to use. And I chose SQL because I specialize in the language. I've used it for many years now, and I thought that it gives me the most flexibility to be able to do this exercise. However, some people chose Excel, others chose Power BI, and then there was Python and R in there as well. But I'm going to be focusing on SQL and show you how I went about cleaning this data. So in this video, the functions that I use most commonly is the cast function in SQL to be able to do your data type conversions, whether I was converting strings from a or from string to text or whatever type of conversions I was doing. I use the cast functions quite a bit. I also use the replace function in SQL to do a lot of string manipulation and to be able to clean out certain characters from strings that I didn't want. And then I use the substring function where I just wanted a part of a string to extract a specific part of a string. And then if I wanted to find a position in the string, then I use the char index function that's available in SQL. And I use the collate function to do language translations when getting rid of things like accented characters in player names and club names, etc. Now I'm using Microsoft SQL Server. So if you're using things like MySQL or any of those, that's also fine. You know what the equivalent function or keyword is for these functions as well. And also, I'm not going to be going through details of how to be able to write SQL or how to be able to use these functions, because I'm assuming that if you're watching this video, you have a basic understanding of how to use SQL. But I just wanted to show you upfront, if you are interested in how I did this, these are the functions you should focus on learning as well if you're new to SQL. First up, I'm going to show you how I went about cleaning player names. The data was given to us in CSV, so I just imported that into my local instance of SQL Server, and I have the table over here that I stored the data in. And once I opened it, this is what the data looked like. So I've got my player names over here, and you can see there's just some issues immediately at face value. You can see there's some spaces in the beginning of the club name. It's not ideal to store year values like this over here. But the first one I'm going to show you is how I cleaned up the player names. Now, if you look at this query that I wrote over here, you can see that these first two columns is what it originally looked like, and this is the cleaned versions of it. Now, as part of the challenge, we needed to do a few things over here. We needed to uniform the short name to have the initial and the surname. So we didn't want a situation like this where you had the player's shortened name like Raphael and then you had A Carroll. So we wanted it to all be the same. So and then the next part is that we needed to handle accented characters like this over here. So where you have, like, if you look at it's not a regular English O, it's a O written in Spanish, so it has an accent. And just to clarify, that is not incorrect, it's actually a language thing. But if you are querying it in English and you type in a regular O, it's not going to bring up these type of records. So we needed to uniform that as well and get rid of the accented characters. So when we query the data, we'll be able to get the results back for the player. Now, the first thing I'm going to speak about is how did I get rid of the accented characters? Well, I did two things over here. The first thing I did is I applied a collation rule. Now, what is collation? Collation just simply determines how data gets stored in your database. So depending on the country that you're in, or the language that you're speaking, or the language that this specific data is going to be presented in, then you will set your collation rules based on that over there. If you're not familiar with collation, that's fine, you don't need to worry about that for now, but it will be great reading material for you to go and study more on that over there, because collation is really important if you want to know how to use SQL. Now, So in this specific case, Latin 1 general is great for Greek, if I remember correctly. So there's not a lot of accented characters over there, and it gets rid of most accented characters. However, there's still some other languages, like especially Turkish and so on, where some accented characters get left behind. And for those that this collation rule doesn't clear out, I created a scalar function which simply just goes and searches through the string for for some of these characters and replaces it accordingly. So in my query, you can see that I call my string, which is not string, my function that's called fn replace foreign chars over here, and that goes through and will start removing a lot of these uh, accented characters. As you can see that I've missed one over here where there's under the y, so I can simply just add that to my function over here. And so if I just do this here, you can see, so I can just add this y to my function, and then I'm going to replace it with the regular English Y. So that's it. It's as simple as that over there, and then I just update it, and that's it, done. So now if I had to rerun this over here, it should in theory take out that accented Y character. And so that's it. The difficult part was probably handling the accented values, because like I said, it's not incorrect, and here we go, it's out of my in my clean string. It no longer appears there anymore. It's in the original ones, but it's no longer in my clean strings. So there's a practical example of the type of issues that I had to deal with here when getting rid of accented characters. So you're effectively just doing some type of language translation. Then the next part is, how did I go about uniforming the short name and getting the initials, and then the rest of the player's name. So what I did was, over here I used what we call the I use a combination of having the concatenation function, which concat means exactly that. It's string concatenation, so that you can build up a string over here. And then the first thing I did was to say, okay, using the left function is to get me the the left function and get me the first character of the long name of the player, and that's where you get the s. The next part of my concatenation is to put a dot after the initial, and then after that, over there, using the substring function, you find the position of the first space in the long name, and then display everything after that. So I just said, okay, find me the string location of the first space, and then use that as the starting position for in the substring function, and then give me the next 50 characters over there, and that's it, done. You've now have a uniformed short name. So that's why I say, like, I'm not going to go into too much detail of necessarily how the substring function works, or else this video will be very, very long. But this will give you a practical example of how I did it, and you can learn more about the substring function and how char indexes work. The next column that I want to show you how I cleaned up is the club names. Now, the club names were a little bit more easier to do than the player names, and I just want to show you why. So there was not much manipulation that needed to be done over here. The biggest one is, how do you handle taking out the spaces at the beginning of the club name? Now, these were not actually spaces, because initially I used the replace function and I searched for spaces, and the only spaces that was there is in between the team names, like where it was ADO Den Haag. Then that you had spaces in between those words over there. That was the only spaces that it removed, and it did not remove the spaces at the beginning. That's because they're not actually spaces. They line break or new line characters. And if you've ever worked with Excel before, and you saw, like, the when you hit the enter button on or the enter key on your keyboard, and it goes to the next line, that is a line break character. So that's why I couldn't pick these up as spaces. And in ASCII, your Line break characters are actually called char 10 or char 13 depending on your operating system. So what I did was, using the replace function, I searched for char 10 in the club name, and then I replaced it with an empty string, and as a result I no longer had those spaces at the beginning of the club name. And then the same function that I wrote for removing accented characters from the players names, I applied it here as well. I called it for my club names so that I can remove the accented characters. As you can see over here, there are a few of them here as well. And then also I applied the same collation rule as I did here earlier so that I could get rid of a lot of the other accents as well. Okay, and those were the only things that I needed to do. Very easy over here. Yes, this is the original, this is the clean version, and that's your club names cleaned up. The next requirement in the challenge was to convert the weight of the player from kgs to pounds. And it sounds easy enough to do, but you'll see why it wasn't that straightforward. And when I show you what the data looks like, so I'm just going to run this over here. This is what the original looked like, and this is the cleaned up version, all reported in pounds. As you can see, first problem over there is that you have kgs and pounds mixed together in one column. And if you've worked with data, you know that that is not ideal, because you should not be mixing up different units of measures in the same column, because then you will not you're not supposed to do it, because if you add it up it won't make sense, right? So that was the issue over here, and we needed to get it all into pounds. So did I go about doing that? Well, again, using the replace function, I was able to go and, first of all, having to strip off the latest kg or lbs, because when you're working with numbers, you cannot be having text in those columns, so you have to strip off all of those letters first before you can try to convert it into a numeric value and then convert it from kgs to pounds. Okay, well, how did I go about doing that? Well, I used a case statement over here, and I'm doing a test to say, okay, well, when the weight has contains the string lbs in it, then simply just replace the letters lbs with an empty string, and that will result in, instead of having 176 lbs, you're now just left with the number 176, which is perfect. That's what we need. We need this in a numeric value. Now we're going to do a similar thing for kgs, but it's not that straightforward, because we need to also convert it to pounds. So then the next part of my case statement is, when the weight contains the letters kg in it, then strip out the letters kg and replace with an empty string, which is perfect. And then I cast that as a numeric, as an integer, because I need to apply a calculation over here. Now I've got it as I got my kg value, and I take those kgs, I multiply it by 2.204, etc., and that's the conversion from kgs to pounds. And now I have a column which has all the players' weights uniformed in pounds. The next part of the challenge was to uniform the player's height column. So here also there was a mixture of feet and a mixture of centimeters. There was no specification given as to which one we should use as a unit of measure, so I just chose centimeters anyway because I prefer that. Now, in a similar situation to how I went about converting the weight of the player from kgs to pounds, I did similar over here, and I started off by saying, well, this is what the original looked like, as you can see. So I started off by doing a case statement and say, okay, well, where the height contains the letter cm, replace cm with an empty string, and that gives me this here. So that was straightforward enough. However, when you doing feet, then it becomes a little bit trickier. So how did I go about doing it? Well, I had to use the substring function to split up the feet and the inches over here. And once I got that over there, I could convert feet to centimeters separately and inches to centimeters separately, add the two up together, and that will give me my height in centimeters. So how did I go about doing it? Well, first of all, I used the substring function to go through the height column and get me everything up until the single quote, and that's how I know that I've got all my the feet. And then the next part is to give me everything after the single quote right till the end, and then I know that's how I got my inches, right? And then once I've done that, I just say, okay, well, multiply the feet by 30.48, and then and that will convert the feet to centimeters. And then for inches, multiply this column here by 2.54, and now I've converted the inches to centimeters. And then once I add those two values up, there you go. You now have your value over here of 185 in centimeters, and there we have it. We now have a uniformed column for the height in centimeters. The next column that I decided to work with was the start and end dates of the players' contracts. Now, the details around this was also quite vague, which I suppose is fine because it's not it wasn't detailed specifications. It was just a challenge to see, I suppose, how flexible we are and how each individual interprets this, which I suppose is perfectly fine. But I decided to do a few things over here to make my data a little bit more intelligent. So this is what the original looked like in the original column looked like in the data set. And as you can see over here, you have your contract start and end years, which has this dash in the middle of it over there. And then you also got, if the player is on loan, then you have the date that the loan has started, and it says on loan in it. And then as you go further down, you can see it, this player is free. So I have quite a few mixed variations to work with, but in terms of how you would want to prepare this data, that's not cool, that's not ideal. And then this is how I went about doing it. So the first thing I actually did was something that wasn't part of the specifications, but I thought it will make this data set more intelligent, and that was to create a contract type column which will indicate whether the player is permanent, whether they're on loan, or whether they're free. So in this case, I know that the on loan players, it tells me in the contract column that they're on loan. So I know that. So in my contract type column, I have a case statement which builds up this column and says, well, if the contract column contains the string on loan in it, then display the word loan, and that's it. And then for free, it was easy enough as well for players who are free agents. If the string contains the word free, then uh, display the word free. And for permanent, well, see, there was no indicator in the data that the player is permanent, but we can logically tell that yes, the player is on a permanent contract. And these are things that you'll need to look out with when working for data. Sometimes you have to look at the data and determine what it logically means, and then apply rules on your data set accordingly. So in this case, I said, well, I know that there's one identifier over here, it's this dash that tells me that it's permanent. So I said, well, where the contract column contains those dashes, display the word permanent. And now I had a very nice column to work with, which actually shows me what the status of this player's contract is. So I call it contract type, you could call it contract status, or whatever it is, doesn't matter. And now you can actually use that column to filter on. Okay. But the next part is the contract start here. So how did I go about getting that? Well, here we go. So again, using a case statement again, I say, well, if the contract column contains these dashes over here, then give me, using the left function, I want to see the first four characters of this contract, which is 2007. So starting from So it's a left function 4 of the contract column, and that gives me my start here. That was a very easy one to do. And then where the contract column contains the word free, then we know display a null value over here because we don't have any start or ending here, and the same goes for the end date as well. Display a null value because we don't you don't have a start. It's not applicable for free agent, so that's fine. Now, how did I do it for on loan players? Well, that gets a little bit more trickier, where when the contract column contains the word on, or contains a string on loan, then that's when I start using my substring function, and I say, okay, well, the starting position of my where of the string that I want to extract is everything after the comma and the space, which is over here. So you'll see it's Jan 4 comma space, and I'm saying, okay, everything after that over there, uh, well, because I applied the +2 over here, so once it finds it, +2, so it starts off at 2021, and then give me the next 4 characters over there, and that's how I end up getting the extracting the value of 2021 out of this column over here and into my contract start here. And that is it. Now I have the start here for my contract, for the loan contract types or the loan players. And then similarly for the for the contracts end year for permanent players, again I'm saying, well, if you look at this part here specifically, again I'm using the wherever the case statement to say, well, check to look for a value for these dashes over here, and then use a substring function to find everything after the dash, and then go and get me the next 4 characters, and that's how I get 2025 into my contract India. And then, like I said, for free agents that doesn't apply. And then for loan players, there was actually a loan date end, so that was simple enough, where I used the left function, and I got the first 4 characters, and that's how I ended up getting my year stripped out of the loan date end. And now I have uniform columns for contract start and contract end year, and as a bonus I also have a contract status or contract type, which I can use in my final data set to do filtering on as well. The next one I'm going to focus on is the monetary columns in this data set, which was the player's value, their wages, and the release clause, or the release value of their contract. Now, what was nice about this one, I suppose, is that the same issues applied in each one of these columns, where you had a situation, if you look at it, where it shows the value in euros, and it's got the so it's 36 million euros, which is perfect, but the requirement says that we must display this value in dollars, which is fine, because once you have stripped out these the alphabets out of this here, and you've converted it into euros, then applying a dollar valuation to it is easy enough. But like the others, we need to do some string manipulations first, and let's focus specifically on the player's value, because we're going to apply the exact same rules to the wages and the release clause anyway, so we don't really need to look at that for now. So just looking at the values only, you can see, like there, so like I said, this is the original. Now, how did I go about removing these columns? Well, again, using a case statement over here, I said when it contains the letter M, I know it's millions, remove the M, and also remove the euro symbol, because remember that symbol there is text. So if there's text in there, we can't convert it to a numeric value, and which means that we won't be able to, if we can't convert it to a numeric value, then we won't be able to apply a dollar valuation to it. However, there's still one problem over here, is that it's 36M, not 36 million, and we need to convert that number into millions. So how did I go about doing that? Well, after I removed the euro symbol and the m, and the m using the replace function. So I have nested replace statements. The first one goes and does a it removes the euros, and then the next one, the outer replace, removes the m, and then I cast it as a float value because I didn't want to specify how many decimals because I wasn't interested in doing that over there. So I just did it as I cast it to a floating point value, which is fine. And then I multiplied that value, that 36, by 1 million. And then I ended up with a euro value of 36 million. And that's it. And then I did the exact same thing wherever you're seeing the letter K. I know that's thousands. So I said, okay, if the value contains a letter K, again, strip out the euro symbol, strip out the K, convert it to a floating point value, and then multiply it by 1000, and now you have 700k being reported as 700,000. So that was it. That was sorted. Now, so I kept my euro values over there because this is the base currency that the data was given to us anyway. And then the next part is I took that exact euro value and just multiplied it by 1.06 to get my dollar value. Now, there are some other smarter ways of getting your exchange rates. If you want to automate that process and get the latest exchange rates or whatever, there's ways of being able to scrape that data from the internet, and keep your currency exchange your exchange rates up to date. But for the purpose of this specific challenge, I decided to keep it as simple as possible for now and just take the current exchange rate that was applicable at the time. And there you have it. So now I removed all the alpha characters. I converted that into a numeric value, which is in euros, and then I applied my exchange rate and converted that to dollars. And whatever I did for the value, again, like I said, I did the same thing for the wages and same thing for the release clause. And now I had a uniform set of of uh, um, of euro values in my. One of the requirements was to report certain player attributes as percentages. Now, percentages are quite interesting because if you've ever worked with things like Excel before, or Power BI, or any visualization tool, you understand that um, when you convert a number to percentage, what does it do? It multiplies it by 100. So if you have a number like this, so these were the original attributes. If you look at it, the OVA, which is the overall, the player's overall ability, it's showing 47 over here. Now you can store that number as is, and you can logically read it as 47%. But if you display this on a chart or on a table in Excel or whatever, and you convert this value into percentage, it will display it as 4,700, which you know is incorrect. So how do we go about doing this? Well, simple enough. There, in if you look at what I did over here for these three columns, all I did was divide it by 100, and in my data set, I'm going to instead of storing it as 47, I store it as 0.47, or whatever the value is. And so when I add it to in when I analyze it in Excel, and I format that column in as a percentage, it will automatically multiply it by 100 and display it as 47. So it was as easy as that to be able to take those numbers and divide it by 100, and then you have a percentage. And then the last column that I want to look at, or the last columns that I want to look at, is the columns which had player star ratings for specific metrics for that player, and I want to convert that to numeric values. So in this data set over here, there was some columns which were, if you look at the original one, this SMs, and it's the player skill move ratings, and you can see it shows that he has a 5-star rating or 1-star rating, and so on. But remember, when you have these stars, it means again those aren't numeric characters, which means that you can't treat these as measures. So what did I do over there? Well, simply put, I just applied the left function to this particular string, and I said I just want the first character. I could have used the replace function and also just remove the star. So there's more than one way to kill this particular bird, but it's fine. There's no problem over there. You can choose which method you want to use. I just felt that the left function was easy enough to do, so using the left function on the SM column, just get me the first character, and that was it, done. And then I cast that as an integer, so I converted from text to integer, and now I had my SM rating, which was my numeric character. So this is what my final data looked like once I had combined everything, all of those various queries that I was running as I was going through this video, and you can see that I've got my the player ID, I've got the club names and all cleaned up, the player's name, etc. There were other things that needed to be taken care of in this data set, but I don't want to focus too much on those because I felt that it wasn't as important to go through in this video. But like things like the photo URL, which the link had now been outdated. I think it initially had 21 underscore 60 over here, in the original data set. Now it's year 23, so we just needed to replace 21 with 23, and then the link would work. And there were other things like the this column over here, the original other position. You have a primary position, which is the best position column, which was fine, but in the other positions that the player plays in, the values were separated by commas. Now I don't like that, because if you are taking this data and you exporting it as CSV and you are using a comma as your separator in your CSV, then that is a problem, because now you have commas where they don't belong. And unless you're using double identifiers, but I don't like that anyway, so I just replaced those commas with semicolons to make that work better for me. And here we go, that's it. I've just put all of my columns together, and now I have a clean set of data to work with.